welcome to Algebra 1. This is Unit 2 Assessment Review. So let's dive right in. Rewrite the equation to solve for b. When you ask this question, the one thing to see is that locate your b itself. Where is it? Where are you? What is the thing that you're trying to solve for? Where is that located? And it's right here in this case. That's weird. Okay, so the b is right here. You want to get that by itself. An equation has two sides, the right side and the left side, right? An equation has two sides, the right side and the left side. Looking here, b is on the right side. We want to isolate that b on the right side. So your job is to figure out what else is with b that's stopping you from isolating it. Right now, I see a 1/2 and I see an h that's stopping me from isolating my b. Next thing, pick one. Which one do you want to move first? See here, all of them are being multiplied to b. It's 1/2 times b times h. So you want to undo multiplication. How would you undo multiplication? Well, 1/2 you're going to have to times by 2 to get rid of that. So you get 2a equals b times h. How do you get rid of h? Well, you're going to divide by h. So you get b equals 2a over h, and that is your answer. That's an h. Okay, alrighty. Question number 2. In equation above, if a equals 12 and b equals 8, can you find the value of h? So pick one. They are both same equations. I'm gonna pick this one just because like this is the original equation. I could have made a mistake here. I didn't make a mistake, but you could pick one that's already given to you. I'll pick this one. Okay, a equals 1/2 b times h. Now I know what a is, which is 12. I know what b is, which is 8, and then I'm looking for h. 1/2 times 8 is 4, right? And then how would you solve for h? You're gonna have to divide by 4. So h is 3. Cool. Let's go to the next one. So you're given this equation, solve for r. Very first thing, so you're trying to get r by itself, right? Again, think about it. Separate your two sides of the equation. Your r is on the right side. What else is with it? You have t and 2. So the 2 is the bigger thing, the outsidemost thing that's happening here. So you want to get rid of that first, right? You want to get rid of the +2 first by subtracting it on both the sides. You see, when you do it on the right side, you must do it on the left side as well, right? -12 minus 2 is -14 equals t times r. Now this becomes easy. I can just undo multiplication by dividing t. So r m minus 14 over t equals r. That is my equation. Perfect. Okay, so given this, let's do this. Solve for y. First thing, locate the y. It's on the right side. 2x and 3 is with it. 2x is being added to the term 3y. So in order to undo that, I must subtract 2x because it's being added to 3y, right? And get a minus 2x equals 3y. Now 3 is being times by y. So how do you undo multiplication? You're going to have to divide it, right? So I can divide by 3. So a minus 2x divided by 3 equals y, and that becomes my answer. Cool. Same thing here. Solving for p, locate. It's on the left side. 12 minus 2p. Now here's the thing. The term with the p is being subtracted. Now when I think about it, I don't want the term that I'm solving for to be negative. So what I do right away is bring this to the other side, bring the term itself to the other side by adding 2p, making my p positive, right? So you get 12 equals 3m plus 2p. That's a p. Now we're going to have to subtract 3m you get 12 minus 3m equals 2p, and now you're going to divide by 2. So p equals 12 minus 3m divided by 2, and that is your answer. Cool. Question number 3. Solve for x. Now when I look at this, I can think of two different ways of solving this. I can simplify this into making sure it looks like this. Let's take both the routes. Okay, I'm going to take both the routes of what I would do solving this problem. The first route I would take is maybe to simplify it. I get y equals 1/2 x, distribute the 1/2, you get 1/2 x plus 1, subtract 1, you get y minus 1 equals 1/2 x, and then you're going to times 2, so you get 2y minus 2 equals x. If I times 2, I'm going to have to distribute my 2 here, right? If I do that, so that becomes 2y minus 2 equals x. That's one way of solving it. The second way is, this is my equation, y equals 1/2 times x plus 2. What if I just multiply by 2 right here, right off the bat, right away? Multiply 2 on both the sides. I get 2y equals x plus 2. I subtract 2. I get 2y minus 2 equals x. The fun thing about math is that as long as you're doing everything that's logical, you will get the same answer, right? If you, what was the separate thing I did here? One was that I distribute the 1/2 and then solve for x. Here, because 1/2 is being multiplied by x plus 2, I did times 2 to get rid of that 1/2 on both the sides, and the equation just became even more simpler, right? So it really depends on how simplified you want the equation to be, and you get the same answer, right? You get the same answer. So it really depends on how you think, if that makes sense. Question number 4. 3x plus 2y equals 2 times y minus 1. Here, you could divide by 2 at first. That would make sense as well. Again, there's nothing wrong with that, but I think it like by distributing my 2y, distributing 2 inside the parenthesis, I get 3x plus 2y equals 2y minus 2. You're solving for x, so I'm going to subtract 2y on both the sides. I get 3x equals negative 2, because 2y minus 2 cancels out, so x equals negative 2/3, and that becomes your answer. Cool. I don't think you can divide by 2 here. I think the only thing you can do is simplify. I don't know, that's a very weird thing. Okay, doesn't matter. Question number 5. Solve the system of equation using substitution. Well, the word substitution basically just means you need to figure out what one variable equals. So looking here, I see x plus y equals 12, so I'm going to subtract y on both the sides. I get x equals 12 minus y. Why did I do this? Because once I know what x equals in terms of a variable or something, I can use that information in the second equation. I can use this information here, right? So I know that x equals 12 minus y. That means instead of x, I can substitute 12 minus y, right? So what does that look like? Well, it's 2. I see an x there now. So instead of x, I can write 12 minus y. Substitution basically means what it says. Let's substitute. You're going to have to get one variable equal to each other, equal to something, and then plug it in back into the second equation. Now, simplify this, solve for y, you get 24 minus 2y minus 3y equals 14. That is, you get, this is, subtract 24 here, you get negative 5y equals negative 10, I think, right? 40 minus 24 is negative 10, divide by negative 5, so y equals positive 2. Now, when you talk about system of equation, you see we are looking at a point where it connects, right? Where the graph intersects, kind of thing. And when you have that, y equals 2 is not a point. A point is something x comma something y, some y. We know this is 2. We need to figure out what is x. We know x is 12 minus y and y is 2. If I use the information here back, I get 12 minus 2 and x becomes 10. So your answer becomes 10 comma 2, and that is your answer. Right? If you leave it at y equals 2, that is not your answer. Y equals 2 is a line. 10, now x equals 10, y equals 2, that's a point. When we talk about solution to the system of equations, it's a point, right? It's not, I mean, for now, you know, we're looking for the intersection point. A school collected money from ticket sales for a play. They sold adult tickets for $12 each. See, we don't know the number of adult tickets that were sold, so we're going to name that X. Student tickets, we're going to name that Y. So if the school says that they sold 152 tickets in total, that means that X plus Y must equal 150. Right? They sold X number of adult tickets, they sold Y number of student tickets, but total they sold 150 tickets. And the amount that was collected, that was $1,400. Well, if they do 12 for one ticket, and if they sold, let's say, 10 tickets, that'd be 120. It would be 12 times X, right? So it's 12x plus 8y, because $8 is the price for the student tickets and y represents how many tickets they sold, equals 1,400. Solve the system equations by graphing. So you're going to have to take out your Chromebook, go to Desmos.com thing, whatever the Desmos calculator, plug these equations in, figure out where they intersect, and that becomes your answer. It's going to be a point, because it's asking you to do it by graphing, right? Alrighty, question number 7. They are asking, a farmer sells eggs in small cartons and large cartons. Again, right by saying this, X becomes my small cartons and Y becomes my large cartons. I mean, that's straight off my bat. And oh my god, she sold 90 cartons. Okay, so that means that X plus Y must equal 90. If X represents the number of cartons that are small, Y represents the number of cartons that are large, together there were 90 of them that were being sold, that were sold that day. Okay, each small carton has 12 eggs, that means 12x. Each large carton has 18x, that means 18y, and the total that was sold was 1380. Can you solve the system equation using substitution? Well, substitution again, to get x equal to something or y equal to something. Here I'm going to let x equals 90 minus y. Okay, plug it in here. I get 12 times 90 minus y plus 18y equals 1380. 12 times 9 is 1080. 12 times 90 is 1080 minus 12y plus 18y equals 1380. Subtract 1080 from both the sides. You're getting y by itself now. So you get negative 4y equals 300. So how is y negative? Let's see here. Oh, it's 18, that's why. Okay. So this is 10y. So y equals 30. Negative 12 plus 18 is 6. Oh my god, what am I doing right now? Negative 12 plus 18 is 6, right? And 6 divided by 300 is 50. So y equals 50. That's what I meant. Okay? So y is 50, because you're going to divide by 6 on both the sides. So y is 50. And you plug it back in. X equals 90 minus 50. So x equals 40. So there were basically 40 small cartons that were sold and 50 large cartons that were sold. Cool. Going to the next one. Solve the system equation using elimination. Well, when I see this, elimination means I need to eliminate one of the x's or the y variable. How do I do this? Well, there's a 1 here and there is a 1 here. I need to subtract them. 1x minus 1x cancels out. 3y minus y becomes 2y. 4 minus 8 equals negative 4. So y equals negative 2. That's it. So now plug it back into the equation. You get x plus y equals 8. X minus 2 equals 8. So x equals 10. So your answer is 10 comma negative 2. Okay, question number 9. A local gym, the monthly subscription fee is 25 with an additional, so so at a local gym the monthly membership is $25, so it's plus 25 with an additional, so 25 M I would say it's per month. I don't know if it's per month, but monthly membership fee, yep, with an additional cost of 25 M plus 2C, right, equals 45. I mean, depends if M is being monthly here or not, but yeah. Well, if it's not being monthly, if it's a one-time payment, I think it's a monthly membership fee, so it's 25 M per month plus 2C per additional class for fitness that they attended equals 45. So I think C would be 10 in this case for that specific month, I guess, yeah. If the first month M equals 1, but if they're talking about like per month they're doing that, then it will be 25 M plus 22C. But since they're saying it's 45, I'm assuming it's for 1 month, so it's 25 plus 2C equals 45. It depends on what options they're giving you, right? Otherwise, if you are taking the general equation, 25 M plus 2C is what they will be paying, I guess, on that specific month. Right, I guess 25 is the monthly fee, right? So that's not depending, it's not increasing every single month, right? So it's 25 plus 2C equals 45. That makes more sense, yep. Because 25 is the per month, that becomes constant, that remains constant, right? Cool. Your C would be 10 in this case. Yep. Solve for Y, again, simplified, 25 plus YY equals 6Y plus 18. Subtract YY, subtract 18, you get Y equals 7. A bakery charges a $10 setup fee plus $2 for each cupcake ordered for a party. The equation for the total cost is Y equals 2x plus 10 and stuff like that. The point 15, 14, okay. So the 15 represents how much cupcake they bought, right? Because X is the number of cupcakes, right? X is the number of cupcakes ordered. So 15 represents the number of cupcakes they ordered, and then 40 represents the cost that they paid total for ordering their 15 cupcakes, right? That's pretty easy. Oh, that's simple. Okay, question 13, this is the last question. What does the point 4 or 400 mean in the context of the problem? Well, what does the X represent? Because this is the X and this is the Y. X represents the number of bikes, right? So 4 represents the number of bikes. 400 represents the total cost for renting 4 bikes, right? 4 bikes, 400 cost to rent them. If Angel's family pays $600, that means they paid 600, which is right here. So if I track it, 600 meets here, and the X value is 8. I know that information just by looking at the graph. The question is, how many bikes did they rent? Well, we know it's 8. We know it's 8. Well, this is the end of the video. Hopefully this helps. I have a great class, I guess.